Identifying parts of a logical statement. So here's a conditional. It means it is an if-then statement. You guys know what an if-then statement is. It has a hypothesis and a conclusion. So my example is, if a figure is a polygon, then it has sides. Now the P and Q represent each phrase shown in the bracket. It means a premise, and Q is the conclusion. A premise is also called a hypothesis, just in case if you don't know what that is. So here's a converse. It is a conditional but flipped. Notice that the letters are also flipped. If a figure has sides, then it's a polygon. Biconditional statements will come later, but I just want to point out that for a biconditional statement to exist, both converse and conditional statements are true. We'll talk about that later. So here's an inverse. An inverse is a conditional with a negation in front of it. That means it's the tilde symbol, which means not. So it's read not P, then not Q. Notice the word not is in front of the premise, which is the letters. So here's a contrapositive. If a figure does not have sides, then it is not a polygon, which is also true. So notice anything? It is converse, but also the inverse, which makes this statement flipped and inverted. Now back to the biconditional statement. So I was talking about that the biconditional statement is a statement that is both the conditionals and converse are both true. So the conditional is, if a figure is a polygon, then it must have sides. And the converse is, if a figure has sides, then it is a polygon. Notice the truth values. It is a good habit to put truth values by a logical statement. The back and forth arrow down below is read if and only if. As you can see, the statement is, a figure is a polygon if and only if it has sides, which is also true. Here's an example. Let P represent Brent works this summer. Let Q represent Brent takes a vacation. Symbolically represent the following argument. If Brent works this summer, then he will not take a vacation. Brent takes a vacation, which is going against the initial conditional statement. That's the argument. Therefore, Brent does not work this summer. So the solution will be on the next slide. Pause the video and I'll meet you on the other side. So here's the solution. It is read as, if P, then not Q. Well, you have a Q, so that means it has to be not P since they're both flipped. Thank you for watching this video, and if you are having trouble, be sure to watch the video again.